Hi, my name is Mark Walzer, and my presentation is about interactions between underrepresented students and STEM faculty during the COVID-19 pandemic. I chose this topic because a major topic in American higher education is graduating qualified STEM professionals. As a reminder, STEM stands for Science, Technology, Engineering, and Mathematics fields. This topic has been considered a challenge of late due to the changing demographics of the undergraduate student body. This trend coincides with persistent inequities in STEM degree achievement. Studies have shown that while interest in STEM programs is held by a diverse array of students, the population of students who complete a degree is far less diverse. Specifically, Black, Latinx, and female undergraduates have all been recognized as underrepresented student populations in STEM programs. To continue successfully graduating students, STEM programs will have the responsibility of helping these students succeed as they become a larger part of the overall student body. How can we engage these students? According to higher education theorists, positive interactions with faculty can help undergraduate students succeed. This general trend has been supported by research, but the identities and experiences of both students and faculty can affect the outcomes of their interactions. In some cases, underrepresented students report dissatisfaction with these interactions with faculty and consider the faculty members do not appear invested in their success. These differences suggest that interactions between underrepresented students and STEM faculty should be studied further. Another variable affecting these interactions is the context in which they take place. During the COVID-19 pandemic, this context changed dramatically, with remote learning implemented quickly, including by faculty members with little prior training in online instruction. For these reasons, the instruction offered during the pandemic's height has been called Emergency Remote Teaching, or ERT. Because of its recency, I wanted to document the experiences of students and faculty during this time. These trends have all informed my dissertation research. To study STEM student-faculty interactions during the pandemic with a focus on underrepresented students, I designed a mixed methods study. The first phase involved a quantitative analysis of survey data, and the second phase involved qualitative interviews organized around the themes discovered in the first phase. For this presentation, I will focus on the first phase, since the second phase is still ongoing. My quantitative research involved the analysis of responses to the National Survey of Student Engagement, or NSSE, a well-regarded national survey of first-year and senior undergraduates. I used data from the 2020 and 2021 administrations. Because the survey is administered early in the spring semester, most of the 2020 responses were received before ERT went into effect. This pattern will allow for comparisons with data from 2021, comparing the instruction experience before and during ERT. Within these samples, STEM students were identified by a self-reported major. Students in 4 major groups were included: biological sciences, agriculture and natural resources, physical sciences, mathematics and computer science, engineering, and health professions. Because of the size of the sample, detailed analyses could be run by gender identity, race, ethnicity, and survey year. Within this survey, student-faculty interaction was defined using 4 items. These refer to talking with faculty about career plans, working on other projects unrelated to coursework, discussing course-related topics, and discussing academic performance in a course. Respondents were asked to rate how often they met with faculty on a 4-point scale from never to very often. In my analysis, these responses were converted to numeric values for comparisons involving means. The first analysis involved differences by survey year. For the overall sample of STEM students, the 2021 sample reported significantly less frequent interactions with faculty. Chi-square tests supported this trend, indicating that ERT involved fewer opportunities to meet with faculty. For this reason, subsequent analyses involved splitting data by survey year. My next analyses involved comparing respondents by gender, race, and ethnicity. The definition of race and ethnicity used in the survey data is measured by a single reporting variable with 10 separate identities, including prefer not to respond, other, and multiracial. For gender identity, I used respondents who identified as male or female. Other gender identities represented only 1 to 2% of the entire survey sample. Initially, chi-square tests were performed by gender identity and race and ethnicity separately. tests involving gender identity resulted in significant differences, indicating that patterns of faculty interaction were not the same both before and during ERT. Chi-square tests that were run for race and ethnicity by year showed significant differences for working on other projects and discussing academic performance. For the working on other projects item, American Indian, Asian, and Black respondents reported a higher average frequency. The same was true for American Indian and Black respondents for the discussing academic performance option. Because of the size of the NESI sample, analyses could be run within survey year, gender identity, race, and ethnicity. ANOVAs comparing responses by student race and ethnicity within gender identity groups showed significant differences for all survey items. Of these, the item on discussing academic performance had the largest effect size, indicating a moderate difference associated with race and ethnicity within students who identify as the same gender. Post hoc tests showed that Black or African American students reported discussing academic performance with faculty more often. This result fits with other research on this topic. Comparing these results by survey year, the effect size decreased in 2021 compared with 2020. This result suggests that the associative power of this relationship lessened during ERT. Other tests were run to explore differences in the opposite order, comparing students with the same racial or ethnic identities, but with different gender identities. Compared with their peers, Black students reported fewer significant differences for interactions with faculty by gender. Latinx students also reported fewer gender differences in 2021 compared with 2020. These results suggest that underrepresented students' experiences with faculty may differ compared with their peers, involving fewer differences by gender, and also may have changed with the shift to ERT. My next analyses address differences by academic major. ANOVAs showed significant differences in student-faculty interactions by major. A post hoc test indicated that respondents within the biological sciences, agriculture, and natural resources group had more significant differences compared with other groups, such as a greater reported frequency for the work than other projects item. Removing this major group from the sample resulted in no significant differences for the same ANOVA, suggesting that biological sciences students had a different experience interacting with faculty when compared with other STEM students. I also wanted to compare results by institutional variables. 3 NESI variables refer to institutional characteristics: condensed Carnegie classification, public-private status, and institutional size ranges. Kruskal-Wallis tests were run comparing responses to student-faculty interaction items within year by these variables. Several trends were found in both years. Respondents from baccalaureate granting, private, and smaller institutions reported more frequent faculty interactions. The NESI respondents' pre-college academic qualifications, defined by standardized college admission test scores, are also of interest in determining likelihood of interacting with faculty. Kruskal-Wallis tests were run for STEM majors, separated by year, gender identity, race, and ethnicity, looking at a set of score quartiles derived by a single scale, including SAT and ACT scores. For both years, most significant differences involve respondents in the lower test score quartile, who reported more frequent engagement with faculty. Specifically, these students with lower test scores reported talking about career plans and discussing academic performance with faculty more often when compared with their peers. Overall, several trends can be observed from these analyses, indicating differences in student-faculty interactions. In 2021, during the height of the pandemic, respondents reported significantly less frequent interactions compared with the previous year's survey. Despite these differences by year, students did show patterns in interactions by their identity. In addition, students of biological sciences, agriculture, and natural resources had different interaction patterns compared with other STEM students. Finally, student-faculty interactions differed according to variables outside of student gender, race, and ethnicity, such as institutional characteristics and pre-college test scores. The second phase of my research will address these topics in more detail. Thank you.